You know those little power bricks, right? The ones we all have scattered around our homes? We plug our stuff in every single day without even thinking about it. But have you ever stopped and wondered what is actually going on inside this little box? I mean, it seems so simple. You plug it in and boom, your device gets power. But the journey that electricity takes from your wall outlet all the way to your phone's battery, well, it's actually way more complex and honestly pretty brilliant. So today, let's crack open this power brick and see how it really works. All right, so what's the fundamental job of this thing? You can think of it as a translator. The power coming out of your wall is like a completely different language than the power your delicate electronics can understand. This charger, it's the essential go-between. At its core, your charger is what's known as an AC/DC adapter. See, the electricity flowing through your house is alternating current, or AC. It's high voltage and it's constantly switching direction. But your phone's battery, it needs a totally different kind of power, low voltage direct current, or DC, which flows in one steady, calm direction. The charger's #1 job is making that critical conversion. And it does this in 2 main steps. First, there's a transformer inside that takes that high voltage from the wall, we're talking 120, maybe 230 volts, and steps it way down to a much safer level. Then, another component called a rectifier takes that low voltage AC and smooths out its chaotic back and forth flow into that one-way street of DC that your battery can actually use. But it doesn't just dump all that power in at once. Oh no. That's because modern charging is, well, it's a highly intelligent 3-act play. It's designed not just to fill your battery fast, but to do it safely, to make sure it has a long, healthy life. It's less about brute force and more like a very precise recipe. Now, take a look at this graph. I know it looks a little technical, but this is the secret sauce. Engineers call it the PCCCCV charge profile, and it's the reason your phone seems to charge super fast at the beginning and then kind of slows down near the end. Let's break down what's happening. So, stage 1 is pre-charge. If your battery is completely dead, the charger gives it this gentle, low-power trickle just to wake it up safely. Once it's awake, it kicks into high gear, the constant current phase. This is the fast charging part, where it pumps in electricity at the maximum safe rate. Then finally, as the battery gets close to full, it switches to the constant voltage phase. Here, it slows the current way down for that last 20% or so to avoid stressing out the battery. And this chart illustrates it perfectly. That fast-charging constant current phase, the real workhorse, shovels in about 70% of the battery's energy in only 30% of the total charging time. That final top-off, the careful constant voltage phase, takes the other 70% of the time just to gently squeeze in that last little bit of charge. It's why going from 10 to 70% feels like a blink, but going from 80 to 100% feels like it takes forever. So naturally, we all want that fast charging phase to be as fast as humanly possible. So what actually makes a charger fast? Well, it all comes down to a really simple formula with 3 key ingredients: watts, volts, and amps. The total power a charger can deliver is measured in watts, and the formula couldn't be simpler. You just multiply the voltage by the amperage. The higher your wattage, the faster the charge. So if you want to crank up the speed, you have to boost either the voltage, the amperage, or hey, why not both? You know, the best way to think about this is with the classic water hose analogy. Voltage is like the water pressure, and amperage is like the width of the hose, how much water can flow through at once. If you want to fill a bucket faster, you can either crank up the pressure, or you can use a wider hose. Fast chargers, they essentially do both. But pushing all that power creates a big challenge. And that challenge, that real enemy, is heat. Pushing all that power generates a ton of heat, and heat is the absolute #1 killer of a battery's health and its lifespan. For decades, this problem meant that powerful chargers had to be these huge, bulky things just to get rid of all that warmth. But then a new material came along and changed everything. Enter gallium nitride, or GaN for short. You've probably seen this on the box of a new charger. This material has totally revolutionized charger design, letting us build devices that are smaller, more powerful, and much cooler than ever before. For over 50 years, chargers were all based on silicon. And yeah, they worked, but they were pretty inefficient. They wasted a lot of energy just by turning it into heat. GaN is a massive leap forward. It's so much more efficient that way less energy is lost as heat. And because it runs cooler, GaN chargers can be incredibly compact and lightweight, even when they're pushing out a ton of power. How much more efficient are we talking? GaN can conduct electrons up to 1,000 times more efficiently than silicon. That number is just staggering. It's the reason you can now get a laptop charger that pushes 100 watts and still fits in the palm of your hand, something that was just science fiction with the old silicon tech. Okay, so now that we've geeked out on how the technology works, how can we actually use all this to our advantage? Just understanding the process means we can build habits that can seriously extend the life of our devices. It really is all about reducing stress on the battery. First off, try to avoid the extremes. Lithium-ion batteries are happiest when they're kept somewhere between 20 and 80% charged. Constantly charging to 100% or letting it die completely just adds extra wear and tear. Second, and this is a big one, keep it cool. Never, ever charge your phone on your bed, under a pillow, or in a hot car. And third, try to lighten the load. Heavy gaming while charging creates a double whammy of heat that just cooks the battery over time. And of course, a few safety tips are absolutely crucial. Number 1, always use certified chargers. Those cheap, uncertified knockoffs, they often skip the proper safety circuits and can be a serious fire hazard. Seriously. Second, make sure there's good ventilation. Charge on a hard surface like a desk, not your sofa. And finally, when you're done, unplug the charger from the wall. It's safer, and hey, it saves a little energy too. So that little power brick you use every day is a tiny, incredibly sophisticated piece of engineering. GaN has made our chargers smaller and more powerful than we ever thought possible. But you know how technology is. It never stands still. So what's coming next? Well, the next big revolution that everyone's excited about is probably solid-state batteries. This technology promises to store way more energy in a smaller space, be much safer, and last far longer than the batteries we have today. It's a little glimpse into a future where our devices run longer, and our power bricks might just disappear altogether.